today's stream is, we're not doing Grid Runner. What we're going to do is, you know this competition I spoke to you about? Everybody's making games. Everybody. I'm feeling left out. I tried doing chess, but ran out of memory and the computer was cheating. I tried doing... Leave me alone. Anyway. I think he will. So what I've decided to do, I've got another game that I'm working on, but I'm not going to be doing that. You'll probably see it because you'll see the code in a minute. But I thought we'd try and do a very simple game, try and code it. We should be able to do it pretty quickly. And submit that to the competition. Very simple game. Just to help all those noobs, or those people that lack the confidence that they can write a 2K game without too much effort. So, the game, have I still got it on my screen? No, I haven't. Are you going to borrow my game? I don't know. Right, the game, I thought I did my thing and I haven't. Hang on. What do you want? Eh? What do you want? Go away. Go on. Go away. Right, let's see if I can find it. Oh, I had it in my... Oh, I'm missing something, aren't I? Ooh, what's going on here? There we go. Right. It's... Oh, come on. Be there. Oh, you little... Anyway. It's not playing ball again. I'll see if I can find it here. Here we go. It's not the one I've found, but it'll do. Oh, that could be it.
This winter, show yourself a little extra care with the protective balm in Kleenex Balsam.
There! Advert!
For superior soothing, try Kleenex Balsam with Balm Care.
Here we go.
Simon was one of my favorite games growing up, and retro games are always a huge hit here at Marbles. To play, activate the device, watch, and listen as the 4 buttons light up randomly and produce different sounds. Then press the buttons in the same order to progress to the next round. With each round, the number of buttons to press increases, as does the challenge.
Anyway, enough of that. This is what I'm going to try and do in this stream, is to recreate the Simon game, or copyright whoever, and try and make it's a simple game. It's a no thought game. Hi, Stacy Bates. What do you mean someone in the group's done it? Doesn't matter. This is a topic for a stream. So, we're going to try and do it as quickly as I can. So, I have... Oh, forget that. that is my other game that I tried to do in BASIC, but ran out of memory, so I'm having to do a conversion on it. So this is what I'm thinking. Right, this is what I'm thinking. So this is the screen that I'm looking at. So we've got high score, we've got the 4 buttons, lives and a timer. And I think that's what's going to make it a little bit challenging. Because what I want to do is introduce a timer. So when it's finished doing its thing, it then starts the timer off and you have to finish it. So it adds that extra impetus in trying to do it. So that's the screen layout I've come up with. So now it's just a case of trying to code it. And I have some ideas on how to code it. So it's just a case of getting on with it. So the first thing we need to do is, I'm going to shift that away, out of the way. So I've started with some so I've started with a template. So I've got a memory template and I've got my C64 constants file, which I've used for everything really. What I'm going to do is, we have got memory that we can use at 033C. Now this is the cassette buffer, and that has 190 bytes. I know it's a lot. Let me grab my map in the 64. Where are you? Oh, you have to come on that side. Let's get rid of that. Right. You're joking? No? Okay. Oh, okay. There we go. Thanks, Mikroman. Right, so here we have a tape buffer. And if we work it out, hang on. One of the dogs has been told off. We have 1019 minus 828. That's 191 bytes of available memory space for whatever we want. Now what I'm going to do is I'm going to put the combinations. So as Simon goes on, the combination trail is going to go in there. So we could have 191 notes in there. I know we'll never get to it, but it's that is the point of that. And we are also going to use this memory space here, which I think is about 80 something bytes. I've still got the calculator. No, I haven't. So 767 minus 679. There are 88 bytes. That is true, but we are going to use some basic functions. I can't really do that. So we've got 88 bytes of available variable space, and we've got 100 and odd bytes for the combination, as I've called it. So that's where we're going to store the combination, and then everything in 02A7 upwards to 0302FF is going to be available space. So the first thing we need is, I don't know whether to call them vars or not. Yes, that's true. 033A. I think it was 033A because the pet didn't have the 0 byte and the 1 byte as the banking out things, so that's where you gain the 2 extra bytes. It wasn't the Vic 033A as well? Can't remember. Right. So, number of combinations. Combinations. Let's think of something else. Current. Current combi count. No, don't you dare start doing that. And we'll be clever, we'll just do this. So that's the current combination count. So it's either we're on combination 1 or 2 or 3 or 4. Current human location. So that's where you, the human, are currently. So if you're in a 10 bleep stream, we could be 5th in there in that current label game level. Game level lives. Lives. Have I got that switch back on again? Hang on. No? Okay. Game level. Score. Now, how are we going to do that by BDC? BCD? How are we going to do that? Yes, I think we should. Or should I? Yeah, we'll do it. So what, 6 digits I've put it to. I doubt if we'll get anywhere near there. Right, so score. So score will be 6 digits. So high score if we get a chance. Timer. How am I going to do the timer? Yeah, we'll put it in anyway. So what else did I have on there? Score, timer, lives, where we are, combination, the level. Right, so I need, we're going to use the raster to control the game. So as Andy keeps telling me, NTSC is 60, PAL's 50. So there is a I'm sure there's a byte that tells you which is PAL and NTSC. Is there a byte that tells you which is PAL and NTSC? There. There. 02A9. 02A6. Get in there. We'll nick that. Constants. Let's go back up here. Here we go. Well, it's just in case, just in case. So we'll see, oh, with 0 indicating NTSC and 1 signifying PAL. Okay. Okay. So we need, so we've got the timer. We need a, we need a delay, level delay. Level display label. And the reason why we need that is because we want to, as you progress through the game, it's going to get quicker in doing its thing, right? So as you get more and more into it, it's going to get faster and faster at spitting them out. So, and that's where, if we have the level, if we have different difficulty levels, you know, hard, normal, easy, it just means that for hard we'll be already up into the quickness and stuff like that. So that's what I was thinking about doing that. So level display delay. So that's the current display delay. So that's what currently what we're on. FPS. Oh, what? Ooh, undo. So that's gonna be our frames per second. So when we test the NTSC, that's gonna be our frames per second. What else? What frame we're on? Oh, I did spell that right, didn't I? No, I didn't spell it right. There we go. Right, so we need, so I've done a bit of jiggery poker here, and now this is going to have to be changed because I've got my screen different. So I might programmatically create the screen. Yeah, might programmatically create the screen. Was it on the original one? Oh, I didn't know that. Well, it's going to be random because it's not going to be using the basic random routine, which is always always cycle through the same numbers when you restart. So when you restart Vice, if you run it straight away, you can guarantee Vice is going to load it and run it in exactly the same time frame. So it means all the random numbers are repeatable. I'm not going to be doing that. I'm going to be using the SID noise generator, which technically should be random inside of Vice anyway. So hopefully they'll be all different. So let's get started. Right, import. It's hash import, isn't it? So we'll import it the constants. Basic start, isn't it? Oh, is it basic start? Oh, I keep forgetting. It's pinging me on Discord. Oh, I see. I see. I see phase. Yeah, I've just seen it. Right. Where's Grid Runner? Gonna cheat. Oh, Grid Runner doesn't have it, does it? No. Right, we'll do that one instead. Oh, cheers, Andy. There's not a listen in here. Why is that? Oh. Why is that not liking that? Do. Oh. Right, it's basic upstart. Well done, Stacy, you spotted it. So we'll do as import of memory here. Right, so the start of the game. So we're gonna be rotating through it, and so we're gonna have different game modes. Different flow modes. So we're gonna have title, generate the random sequence, and then the computer suggesting the thing, and then the human trying to copy it. So first things first, we need to create the screen layout. So let's do that first. So what character is that? Oi. It doesn't tell me what character it is. That's... Oh, it does. Oh, it does. Yep. Right, so what I'm going to do is we'll draw the four squares, so to speak, and then we will see if we can get it on the screen, and then we'll take it from there. Okay, so create screen layout. So we're going to draw the cell. So draw cell. So we're passing in two parameters, and then we're going to use 0 page to do it. So so I need to put that in here. Right, so one location equals, so the start of cell 1 is 04A7. You'll get there in a minute. Cell 1 lock. Dot label cell 1 lock. Yes, you'll get there. So draw cell. So store A in what we're going to store it in. There we go. We'll store it in that one. 0 page low, 0 page high. So A is low, SDY is high. This updated extension sucks. Right. In fact, do I need to do that? Oh, keep it simple, John. Keep it simple. Right. Horizontal looper. LDY hash 1. This one. This one. I think it got updated. It keeps auto prompting. Its IntelliSense seems to be screwed up. So let's see, what's that? One. Well, I haven't got another ASM. You know, it's on kick down here. So I don't know. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, the two both of them were trying to get to the ASM files. Yeah. Right. Let's do this. So, so we're using the 0 page for our start point. Okay, so LDY #0, LDA hash, what is it? What's the corner? 85. So store that in right, so LDA hash 64, I think the next one was. Yep. Hello Jason, morning. So that's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So CPY #10. Branch if carry clear to horizontal looper. In fact, we'll make that a temporary one. Yeah, I've got my beer, mate. So on the 10th one, we're loading A with whatever that corner is. 73. Store it in 0, Y. Yeah, I've tried workspaces. Sometimes it gets itself in a tiz. By the way, can you see that screen? Is this text big enough? Is that better? Right, where's my... Right, so that's the first line. So the first line's done. So we now need to do 1, 2, 3, 4, 5, 6, 7. So 0, 1, 2, 3, 4, 5, 6. Right, so the first thing we do is if we add it up front and then store, yeah, we should be all right. So this is the vertical looper. Branch of carry clear. Oh, come on, John. To bypass inc 0 page high. Bypass inc. So we've initialized X. We've added So we can, in fact, no, because we've loaded A there, so we'll have to load it here. So now load in with, what's the number? 66. LDY #0, store it in 0 page, low, comma y, LDY #10, I think it's 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, yes, 10. Same again. So increase X, so we've done the first one, compare X with, I think it was 6, wasn't it? 1, 2, 3, 4, 5, 6, 7. Compare it with 7, branch carry clear to vertical looper. So that's now doing the 2 lines down. So we'll do this again here, because we should be somewhere near the bottom. So we need that as well. And we need, where are you? That. Because we've just placed it, so we need to move down a line. Now we're on the bottom line. So what's the bottom line? Bottom corner is 74. Still the same 64, and the other corner is 75. RTS. Right then. So the first thing we're going to do is #chr clear screen, JSR kernel, character out, and then jump to star. So we're going to get it to loop. Right. So we're going to just test out, see if this draws the first cell. Here we go. Hey! Ha! Lucky, 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 lucky. Right, so we've drawn the first cell. I'm just wondering whether... I was thinking of using 1, 2, 3, 4 to control the buttons. Do you think we should use letters? Come on, interaction, interaction. Mull it amongst yourself while I put the other 2 cells on. But it does, oh, right, let me put the other cells, because WASD doesn't seem to be intuitive. Right. So let me put the 4 cells on. 2, 3, 4. So cell 2 is at 04B6. Cell 3 is 0637. And then the last one is at 0646. Right, so where's it? So we need to grab that. So 4, 3, 2. Right, here we go. So there's our 4 cells. Now WASD doesn't link up with the 4 because WASD is 1 and then 3. Right, just for the late arrivers, we are doing the Simon game. The Simon Says game. This fella. This fella. AZ, K and M. AZ, K and M. Okay. AZ, K and M. Okie dokie dokie. Control Alt Delete Escape. No. No. Right, so that's the game we're trying to recreate, yeah? So we've got our 4 cells on the screen. There's no colour yet, just give me a chance, alright? And, right, I'll put, so AZ, K and M. Okay. Have I got them in the constants? I can't remember. No. So what we'll do is, so LDX hash, I think it's this, isn't it? So the first one will be A. Well, that's not going to be right, is it? What's A? Screen code 1. There we go. 01. So this is cell 2. So LDX, so that's going to be K. Screen code 11. So this is 3, so that's going to be Z. 26. And the last one is M, which is 13. So in our draw cell, now we need to test for, so if that's 1, 2, 3, 4, we need to test for 4. CPX hash 4, branch of not equal to bypass letter poke. Put that there. Keep forgetting that. So re-establish the right. So so basically transfer X into A. Store that in comma Y. But first we need to do LDY hash 0, 1, 2, 3, 4, 5. Come on. Right, so that should put the letters on. Ha! D. Did I put it in the wrong register? Or have I used X, haven't I? I'm using X. Ah! Hang on. Hang on. So I'm using X. Yeah, okay. So I've stored A away. Transfer X into A. Push it to the stack. In fact, no. Just for this. I'll do it. There we go. There we go. So, now I've got a square in the middle, and the square I had in the middle was basically the indicator for you to get started. But first, I want to add some... right, so there's no memory taken up there. So here we go, get data section. Okay, data section, yeah. Code section, star code section, where is it? Right, so I want to put a square in the middle. So, right, it's all in the same place. So load A with 112. Store it in wife's home. Store it in 05F2. That's not 05F2. Oh yeah, it is. In fact, nah. So that's 64, I think. Yep, 64. You can't see it because I've got it on the other screen. You'll just have to bear with me for a moment. So that's done that. We'll also store it in the bottom two as well, which is 066B. C. Then we've got the, what's that one? 66. That's going in 0618. Oh 0642. 061D. think the next one will be 045. Yep. Right, do the other corners now. So corner 2, which is 110. Store it in 05F5. Ooh, go away. Bottom corner 109. Goes in 066A. Oh, of course it would be, wouldn't it? And then LDA, look, last corner 125. 066E C. Oh, A, B, C, D. That's A. Wow. What the? Go away. What? Go away. Right, so now that should do the middle bit. There we go. So I've got 2 rows at the top and then 2 underneath it. And the reason for that is I'm going to cheat. I'm going to have 2 rows where we can see what the code is as a debug, so we can see what's going on. Yes, mate. So, what I want to do is I want to colour these. So the original one, have I still got it up? I think it was. So it's green, red, blue, yellow. So what I want to do is I want to be able to colour these. So first things first, let's make everything white. Right, let's made everything white, and then what I want to do is I want to fill the cell with a colour. Yeah. Now, to do that, I'm going to have to create another routine to do it. So we've got this crate layout, this screen layout, and we've got the draw cell, but that's drawing the outline of the cell. And then we've got draw the player. Now I want to draw fill cell. Yeah. So fill cell. And it's basically going to be the same as this. Well, yeah, I would. Right, so let's take that, because we know the cell location. Let's put it in fact, no, we'll take this, we'll take the draw cell and we'll chop it down for what we want. Right, so we, oh, X, yeah, we'll leave X there because that's the colour, that's what the colour's going to be. So, first things first, if I look at the screen, we are a line down, so we need to add 40 straight away. So that's going to put us in the right ballpark. Then ooh, I've just thought this is the colour, isn't it? This is colour. I need to modify this just a bit. Need to do it in here. Yeah, we can do that. We can do that. Right, so right, so I need to fill the cell with the solid blocks. So I'm going to do that here. So we're starting with Y. So we're going to increase Y here. Going to load hash 116. Store it in 0 page. No. 0 page. Comma Y. Increase Y. CPY hash 10. Branch carry clear to fill. There we go. So that should store 160 in there. So that should fill it with, and then we have the problem of the character, don't we? Yeah, but that's easily done. ORA hash 128. That should do it. Right, this is just to fill it in. F5. So we should have filled in cells. Ooh, one out. I need to knock it down by 1. Cheers, Hayes. Oh, hang on. I wasn't one out. I was right. I've just overwritten my... that's the problem. Because I've used A already. I've overwritten A. So let's just do that. Why are you running? Go away. That does it. Should be. Not yet. Right, so I need to do the fill now because I want to fill the cell with the corresponding colour. So fill cell. So here, so we're going to add 40 to it. Increase, but then we're also going to add. So we've increased it. So then we're going to do ADC hash $D4. And store it in 0 page pi. There we go. So then that's now made it into the color RAM, and basically we are just going to load what's in there in there. So we just need to do that. So we've down one line. So store it, increase it by to 10. Get rid of that. Add 40 to it. This is where we need to track the number of lines. So INX CPX hash, how many? 0, so it's 1, 2, 3, 4, 5, 6, 7. If it's, so that's 7. So it's equal, branch if equal to cell filled. If it's not, we're going to add 40 to it, bypass it, and then send it back round to horizontal looper. Then this should be RTS because we've done it. Right, so that should fill the cell with the color. Okay. Draw cell, fill cell. So what I'm going to do is I'm going to see if the colors look all right. Right, so the first colors, what I was thinking of was they're not the colors. No, they're not. Oh, Kick has the colours already defined, doesn't it? So what I was thinking was, where's the colours? C64 colour. There we go. Was that what I was thinking of? Was the colours. Now we've seen that it's green, red, blue and yellow. So what I was thinking of, we need a light green, light blue, just to do the highlight, right? So it'd be dark on the screen. So let's do cell 1 as blue, which is 6. So that's blue. Fill cell, and then do cell 2 in light blue, I think it is. Is it light blue? Oh, light underscore blue. I just need to test, check fill cell. Something in the back of my head's going, it's not going to work, John, it's not going to work. And they would be right. See what they look like. Oh, and the colour's all screwed up. What have I done wrong? So I added 40, increased high, then I loaded page high, added D4. That could be the reason. And why is that? Come on. No. Doesn't help with the background beam. Right. I am not resetting Y, am I? No. Fill finished. Store that. $50 Shades of Brown. Right, so I'm one cell, one out. One out. It's easily solved. Ugh. Gotta do it on the other one as well. Right. So you reckon cyan for blue and light blue, or light? That's more of a purple though, isn't it? That looks like purple. So let's try. What's cyan? 3. Okay. So remember, is the same button. The height, you know, it's like the light's lit up, yeah. So this would be the color without that signifies the blue. You know, let's get back to the picture. That just signifies the blue, and then the cyan color would then signify that the blue's gone lit up, yeah. So that's what I'm picking. That's what I'm thinking. Right. So we've got blue and cyan as the combo. Right, so let's do green. Let's do green. So green has green and light green. Okay, let's try them. Does that work? I think it does. Right, so the next one is red. So we'll do red, and I think there's a light red, isn't there? Yeah, light red. That works. Now, the troublesome one is yellow. So what I thought was yellow could be the light switch colour, but then orange would be the off colour. Like that. And I think that works. What do you think? So we've got our 4 colours, right? So let's fill our 4 cells with the 4 colours. So if we mirror, so we go green, red, yellow, blue. Okay, so green, so this one's green. This one's red. And then yellow and blue. Oh no, it's orange. So that's going to be 3, 3, 4, 4. That didn't copy and paste, did it? Green, red. There we go. So there's our 4 pads that we're going to make highlight and stuff. So what I'm going to do is I'm just going to give you the give you the impression that it's doing it. I'm just going to make something flash. So that's not going to work, is it? Don't know why it keeps putting that on there. Right, so when that's done that, DEX, branch not equal to delay outer. So we're going to do, let's do cell 1. So we're going to do cell 1. So we said this was going to be light green. Delete again. I know this is fast and loose, but I'm just trying to demonstrate it. And we'll loop to here. Right, so this should flash it, hopefully. Well, that's way quick. Let's slow it down a bit. There you go. So that's the sort of effect I'm looking for. So it highlights when it's saying this is me, do it, and then it goes back to dark when it's finished, and then we would mimic the same thing when you press the keys. How can I have any colour as long as it's brown? Well, that's meant to be orange, but it looks brown to me. So now we've got the routines that allows us to make the cell, to put the colour in the cell, and we've got the mechanics to allow us to highlight them. So what I'm going to do is we're going to go create some routines that allow us to, because we're going to have to do it, and I don't fancy doing this all the time. I just want to be able to do cell 1 on, cell 1 off, something like that. Alright, Stacy, I'll chat to you soon, yeah? So set cell 1 off. Cell 1 on. And we'll copy that. Cell 2, cell 2. So cell 2 is red. And we'll copy the whole lot and do the rest in one go. Right, so cell 3, 3, 3, 3, 3, 3. Now, cell 3 was orange, so that's yellow. No, undo, redo. Go away. So cell 3 off is orange, on is yellow, cell 4 was blue, and we said cyan, didn't we? Cyan, yes. So now we don't need to do this, right? We can just say here JSR cell 1 on, and in fact we'll do them all so we can see what they all look like when you switch them on and off. And then we'll do the same, but this time with cell 1 off. So we delay and then switch it off. Right, that should be all of them now doing it. Right, we've got a problem. Cell 2's not doing out. Ah, that's why. There you go. So that's now showing all the colours and how they're going to be when they're going to be highlighted. Right then. So we need to work out the game loop now. So we've got all the mechanics. The user input will be, it's not going to be joystick, it's going to be keys. And we need to put the text on the screen, but let's see if we can get this thing going. Oh, and sound as well. Oh no, how am I going to do sound? Oh no. Yeah. Yeah. How am I going to do sound? Some of you sound folks are going to have to help me out. The SID chips are black art to me. Right. So what I want to do now is we need to work out how we're going to do the game loop. Now, what I mean by sound is the procedural sound, not goat tracker. Literally talking to the SID chip, saying, "Oi, make this noise," and then it comes out with something that you didn't expect. So, yeah, something like that, yeah. Just toggle volume off and on. Right. So we create the screen. I want it to loop through like I did in Neptune Lander. Ooh, that's going back some time, isn't it? That is going back some time. Game flow. Bet that's in game flow. That's the fella. That's definitely the fella. Right, so we need another memory location. Game mode. Yeah, that's it, phase. I just need, so for the different pads should have a different noise, yeah? Different frequency, whatever. So when it lights up, it goes beep, and when the user presses, it'll go beep. So it's just procedural, yeah? It's just procedural sound effects. Is that the... Got to be sparing with the bytes. All right, and let's see how many bytes we're using at the moment. This is all with the nonsense in. Oh, look at that. Yeah, we should be all right. Should be all right. Right, what I'm going to do now is, where did I have a random function in here? No, I didn't have a random function in there. What did I have a random function in? Oh, it was that paranoid thing, wasn't it? When I converted that basic file. Here we go. Paranoid. That had a random function in there. Wow, 2018. That's some time ago. Here we go. Let's copy this. And you'll all recognise who I've plagiarised it from. There you go. Straight out of his GPAC clone game, his randomizer. So I used that in that paranoid conversion I did way back in 2018. Wow. 5th of January 2018. Wow. It's 3 years. Yeah. Select, Control H. Oh yeah, okay, yeah. So this is our randomizer, right? So what I'm going to do is we're going to create a sequencer, and we're going to always, hang on. Number of combinations. So current combi count. So that's where the computer's counting up. Really? Oh. I'll have to play with that. So I'm going to create, I'm going to use Grey Defender's randomization routine to create the randomization sequence, right? So here, number of combinations. So let's copy that. And we'll just put that up at the top here. This is going to be our game loop, but so I want to grab, say, 30 in combinations and store it in there, right? So now we're going to randomly pick out, so get combinations, so LDA or LDX or LDX, number of combinations. And so we need to init the random function. So initialize it and then looper. So JSR. So that gets us our random number. Then I'm going to AND it with 3. So we only filter on 4 different combinations. So it's 0, 1, 2, and 3. So they're the 3 combinations. We don't need anything else. And then once we've done that, we store it in fact, we'll do that. We'll store it. Oh, hang on. Back down. Memory. Combinations. Comma X. INX. CPX with number of combinations. Branch of carry clear to looper. And that's it. RTS. Now I'm going to put a debug function in here because I want to see what it is, and I've got a line dedicated for that, which is going to be address 0450. So we're going to see combinations. There we go. So we're going to see now what it's going to pick. So we've told it to pick out 30, and we're going to run the routine, and it, as well as storing it in O3R combination array, it's also going to store it on the screen so we can see what it's doing. So let's have a look. There we go. Of course, there's a lot of zeros in there. Right, so what we're going to do is, instead of anding it with that, we're going to roll no logically shift right LSR. We're going to LSR it. Let's see what that does. That's better. It's more of a, we could do it again. Could logically shift it right again. You taking a mick out of my taking the mick out of my talking. Right, so that would say, so that would go C, BB, well, God, there's a lot of A's. A lot of A's in there. How can we randomize it even more? Oh yeah. I'll use that because we're not doing anything. So we'll store that in there. We're getting there, mate. Getting there. Trying to get the combination thing to, oh come on, there's a lot of ones in there. Right, okay. That's better. That's better. So AB 3 at CA. AB 3 at CA. Oh, so even the VIC emulation is running through a sequence of numbers. That's pants. The SID random noise is giving the same numbers out. AB triple at CAB. AB triple at CAB. What? I thought the I suppose on the real hardware it's white. It's the white noise generator on the SID chip. That's what it is. So I suppose on the real hardware, am I doing inject RAM? I have no idea. How do you know? How do you know if you're doing inject? Yeah. Is it under auto start? Oh, inject into RAM. No, it's still doing it. Oh, hang on. I thought I changed that. Let's put a little delay in there. Because the user's not going to start the game immediately. Right, let's put delay in there. And then get it. See if it comes out with a different set of numbers. A triple C, yeah, right, okay. Oh, I'm a bit happier now. Right, so because when the game loads, it's going to have a title screen, yeah. So the user's never going to be bang on the same timing when they say go. So it shouldn't get it. They should not get the same number sequence. But just here, it's given us the same number sequence because there's no human interaction in between. And that's why we're getting the same sequence numbers. But I suppose on the real hardware, it should never be the same, no matter what. So we have a lot of zeros there. So what I've done is I've taken the number and it, so it's just got the last two digits, stored it away, got another number, divided by, that's dividing by 4. So it's basically taking these two numbers, these two digits, and then we're doing an XOR between the two. So it's sort of flipping it, I suppose, is a better word. I don't think there's another way of doing it. that'll do. It'll do. It'll do for this cassette 50. Oh, pressed F5 again. A, B, well, that'll be pad 1, 2, well, no, 2, 3, 1, 1, 4, 4, 3. Yeah, that'll do. That'll do. So now we need to, so now we've got our combination. So every time they run the game, you know, or every time they not launch the game, but start a new, you know, press any key, it grabs the next set of random digits, make it long enough so just in case Hayes manages to win the game. So we'll, instead of capturing 30, we'll capture a lot more, and then basically we run through it until they fail, and we'll do lives. I've just lost the game. Well, I'm sure he's going to find something wrong with it. That's why I put a version number on my screen, look. I put a version number on my screen. Just in case people find bugs in it. What? Oh, right, okay. Yeah. Right, so now we've got the combination. We can, right, we need to start working on the game loop. I made you lose the game. So now we need to start the game loop. So we've got to imagine that we're going to have several modes, and those modes will drive how the game works. So we need to, we won't have the menu, the start screen yet, where they press any key, because I want to I want to get all the other stuff done first, I think. So yeah, so we need a time frame for when it's on and off. And we need the modes. So let's get the modes in. So game mode, the first game mode would be title screen. So the next game mode would be, so at the title screen, it's playing to itself. Press space, right, get combination. Get combination. Then the next one would be Next one would be computer says. Human copies. Lost a life. End of game. Sad one there. So end of life would be you're sorry, you've, and then this is your high score, works out the high score and then goes back to the title screen. Yes. Okay. Right. Back to let you Nanda. So in here we are game loop. And we are loading the raster, aren't we? So that's testing for we're off the screen. So then we can do all the jiggery pokery. Right. So I want. Right. We'll do this. We'll get it to pick out 30 combinations, and then what I want to do is get the game to run through the combinations. Right. But we need to do the game setup first. Okay. Not a problem. Let's create a new file. Right. Right. Might as well just copy what I've got in Neptune Lander. Game status, that's game mode. Right, now the reason this is not working is because we are not doing an import. Here we go. So this would then jump to all our different modes. So this one is, where are we? Game setup. So the game's set up, so when it runs through, it's going to... Right. We've cleared the screen already. We need to create... Do those two. And they're going to go, no, I can't do that. So it sets up the screen, and then... we've done the so we need to initialize all the variables, don't we? Right, so current combination count is 0. Current human location is going to be 0 as well. Game level, that's going to be 1. What else we got? Lives, 4. Score is 0. High score is going to be 0, but I need to how many digits did I have for the score? 246. How much memory space did I? Ugh, no, it's 3 in it. And that's going to be 2. Time is 2. 1, 2, yeah. Do the high score as well. Right, so that's the high score. What else we got to set? The timer's going to be set every time we go through the... so every time the computer's done its bit, that's when it sets the timer. So we're not gonna do that. Level display delay. What? No, that's gonna be... Yes, we'll set that up. So the display delay, that's how long the button's going to be highlighted for. So we're talking in frames. So 50 is 1 second, or so it was like it went and then went off, so it's like half a second. So we'll say 30, 25. Current is going to be 0 because that's our current counter. What else have we got? Frames per second. Yeah, that depends on our NTS thing. So LDA. That's it. We'll preset it with LDA #50. Compare this with 0. Branch not equal to not NTSC. So we'll do that. In fact, we'll do that. That's it. So that works out our... Right. What's next? Current frame. Well, that's going to be 0, isn't it? Right. So once we've set up the game, we need to load title screen. Right, so the first one is this. Now we're going to miss the title screen. We're going to go straight into the game. So we're going to do get combination. So we'll rem that out because that's where we're supposed to be going, but we're going to go straight into get combination. Right, GF get combination. So this is the combination that is going to be used for that, because we got a combination for the front, the screen, and now we're going to get the combination for the actual gameplay, which is identically the same as this. So LDA hash, right, the gameplay now. So the compute, so we get the combination, then the computer starts. Game mode. So the combination is 2. It's 2, 0, 1, 2, yeah. So it's going to go there. Right, so now we need to go into the GF, computer says. Right. Right. So current combinac, so that's going to do just one of the sequence. So when we go into it, we need some flags. So we need some flags. Right, so we're having a computer says is on. So this is going to determine our this is going to determine how the computer says stuff. In fact, computer says flag, that's all we need. And then in the constants, computer says start. Computer says running. But hang on. No. Yeah, get next. Computer says display on. Display off. So it gets the next, turns it on, then turns it off for a bit, and then does the next one. So that's get next. And then okay. So let's do that. So LDA computer says compare it, CS start, branch not equal to not CS. In fact, we'll say branch to CS, GFCS, get next. So if it's the start, if we're starting out, so we need to do that here as well. We need to tell it that it's starting out the flag. Can you hear that? Right. So if we're testing for where the computer is going to start up, yeah? So we need to initialize the index of the combination. So that's current combination count. So we need to set that to 0. Oops. Store it, because that is going to then, we're going to read, that is what's going to drive the next combination. So remember, this is going to run through every cycle of the raster. So we've got the combination, we're starting out, so we're doing the current counter, and okay, so we start it out, the lights should all be off. The lights should all be off. Then we want it to do get next. Store it in the flag. RTS. So now we're doing get next. So this is where we go compare with hash cs get next. Branch not equal to gf. What's the next one? GF display on. So this is where we're now getting our combination. Now, one thing that we've not done is we don't even know what our current combination is. Right, so this is where we're getting our current combination. So we're going to go LDX current combi count, LDA combination, comma X, store it in our current combination. So that's now getting what needs to highlight. Okay, that works. That works. So then we need to reset the display, current display delay. So it's starting again. Then we load the next. The next, which is display on, I think. store it in computer says flag, return out. So now we're doing this. This is where the fun begins, because this is where the fun begins. Yeah, I've missed a step here. Right, still current combinations. So compare with 0. Branch if not equal to pad cell 1. No, cell 2. So if it is equal, then JSR, so we're turning it on cell 1. What's it called? Cell 1 on. So we're going to turn the cell 1 on. So we turn the cell 1 on and then jump. In fact, we can do all this up there and just load this back in again. So then compare with hash 1. So we'll just copy this. Go to cell 3, cell 2 on. Oh dear, there's a better way of doing this, but I'll think about it in a bit. So that's going to turn the cells on. 0, 1, 2, 3. So it's going to turn them on. And then this display on is going to do the delay and then turn them off. So we're gonna have it on for level display. Did we set that? Yeah, level display delay. Okay. So it's going to come into here. We are going to increase the current. Hey, Mark. I think everybody's fallen asleep. Come on, machine. Current display. Compare it with the level display. Branch if equal to If it's not equal, we turn out, because we're still running through the counter. If it is, and we'll just do the same here. We'll just copy this lot. I was going to save a couple of bytes on line 100. You mean this here? But it'd still work anyway, wouldn't it? Branch if not equal. If we just load it, if the 0 flag's not set, it'd still work, wouldn't it? Alright. Oh, I'm in Python mode there, putting Python things in. Do the same here as well. Right, I'm going to have to make these into temporary ones. Right, so here we need to turn off the cell. So we've run through our delay. So I'm going to make these into temps as well. Let's just quickly do that. Whoops. And we're going to set it to off. Right. That would then turn it off. So GF display on. So that's where we're going next. But we need to check if it's in the other state first. Branch if not equal to display off. Right, so we've done the display on. Now the display off is just basically the same as this. Same as that. The only difference is we are going to fix how long the off cycle is off for. So next one is display off. If it's not, then it's GF end. And this we are we need to LDA #0, store it in current frame display delay, reset it for the off. That's here. So we increase the frame delay, load it, and we're going to compare it with 10 frames. So it jumps back out, but if it hits the 10, so we've now done the blink. Oh, this is going to be the one. Because we need to that. So it switched it off. We load the current combination count. Did we increase it when we read it? I've forgotten. Get next. No, we didn't. Right, we'll increase it. Load it in, compare it with the number of combinations. Oh, that's gonna throw a fat one, isn't it? Because it's nested. No. Hang on. We've got a maximum number of combinations, but there we're looping through that combination. We need another. I need another flag in there, don't we? Overthinking it, John. Come on, overthinking. Looks like I'm going to fail in building this in one night. Oh well. I'm thinking it's not just a single loop. It's a double loop, because we need it to run through and then run through again. So it's a double loop. But Is that game level? Uh-huh. Because if you go remember right, we're going to get 30 combinations and then we're going to run through it like that. So it'd be 1 and then 1, 2 and then 1, 2, 3 and then 1, 2, 3, 4 and then 1, 2, 3, 4, 5. So we need another indicator in there. Maybe it's not current combi count. Maybe that's the game level. Yeah. I think it's the game level. Yeah, game level is 1. We set it to 1 when we set up the game. So I think we need to say it here as well. And we're not testing it here against number of combinations, we're testing it against the game level. Because if the current combination is 1, so if it's equal to the game level, then we need to up it. If it's not, that means it hasn't hit it. So it's just so we haven't hit it. So we're changing the state to get next and return. Now, if we've reached the game level, then we need to hand it over to the player. So ink the game level. No. LDA. Game mode. Human copies, store it in game mode. But I don't want to do the human bit yet. I want it to do 1 and then go 1, 2, then 1, 2, 3, then 1, 2, 3, 4. So what we'll do is we'll rem this out, we'll ink game level, and then what do we need to do in the computer says, so it's the status flag. So we'll reset the status flag to CS start. So increase game level. So it's going to start it again and run through it again, but this time we're new game level. I don't think this is going to work. At line 83. What's that one? Line 170. Ooh. Okay, I don't think this is going to work, but we'll try it. Let's just make sure. That's me still got the things in, so why have I not put... Well, it put this thing on the screen. And it got the combination. Oh. So it's put it on the screen, but it's not got the combination. It's not got the combination. Why has it not got the combination? We set it here. Right, so I'm stuck somewhere. Right, let's see if it goes through the get combination. Oh, it's crashed. So it's not even got there. Okay. Let's see what's going on with the... So the game setup, it creates a setup. Right, let's put a breakpoint there and find out what's going on. Right, here we go. Let's move to the next one. So it's... $45, $59, OA 59. That's here, that's the same one as before. X is 01. Why is X01? Oh. I hope I ain't done that in everyone else, have I? Okay. What's that doing? Where's the breakpoints? Let's get rid of them. So it's done K and then stopped. But why are the others not on? Why are the other colours not on? Right, K was on, then stopped. Okay, so it turned off, but then didn't go back through. So we'll have a look here. So compare it with 10, branch if equal to here. So we'll put a breakpoint here. That should, when it turns off, it should break. Yeah. And it's turned off and it hasn't broke. Didn't get there. Now why didn't it get there? Is it CS display off? Yes it is. Increase the display counter. Didn't even get there. So we need to see what, right, I need to see what this display counter's doing. And it's not breaking. Are we setting it to display? Oh, are we setting it? Oh. Well, that doesn't help, does it? Turn off cells. Right, that's not helping. We are not changing the settings. End. No, display off. Right, let's try that. Hey, we got a break. Right, so we did the first one. Now it's doing the second one. And it's only repeating. Right, we'll take that breakpoint out. Right. So it's just repeating the first character. Increase the current combi count, load it, compare it with game level. Right, let's put a breakpoint here, see if it goes through that. I don't think it's going through that. Oh, yes, it is. Right. So I'm increasing game level, go to CS start. Ooh, I wonder if I reset. Yes. Oh, that's not good. Not good. I can do it there though. I have to get combination. F5. Right, it's gonna flash red. Here we go. That is really quick. I think we need. I think that needs to be slowed down. Hang on, where's our worker outer? Right, so we're having it on. Right, let's. Right, I need to. Right, let's do the same here. Right, and we'll do this. Right. That's too quick. It was too quick. So 1001. Right, we'll get it to do it on over. We'll get it to do it over a minute, over a second, because it was too quick. Even I couldn't follow it. There we go. Now that's too slow. Oh, decisions. Right, 25, 35. Oh. That's what I'm trying to do. That's what I'm trying to do. So every time the game level increases, I want it to have a negative impact on the delay. So each time gets one cycle quicker. Or even over every 2 levels makes one. Because if you think about it, if you do one cycle and it's 50, it'll be so fast you'll never see it. So I could say 2 or 3 cycles. Well, maybe 4. That's a nice easy number. So yeah, so when game level, every 4th level would decrease the delay. But it's doing it. Yes, the sequence will get... This is running through all the sequences, yeah? Because you'll... What I'll do is I'll get it to do a pause. Let me just get it to do a pause after it's done a level, yeah? Let me grab the delayer. Here we go. Right, so I'm going to get it, so after it's done a level, and then it goes cycle round, I'm going to get it to pause. So here, I'm just going to get it to pause. So you can see when the level's changing, yeah? To be honest, I could, let's do that now. So let's do that. So I could do that here. So if I load game level and divide it by 4, so that's logically shift right, oh, would that work? If I wanted to make it increase on every 4th, if I divide it by 4, let's work this out. So 5 divided by 4 is 1. That's no good. I want it to do it on every 4th. Oh, I know. And it with that, compare it with 3, branch if not equal to exit, which is here. If it is a 3, decrement the what is it, game? Here, level display delay, because we don't set it again, we only set it in game setup, so this we can decrement and it will slowly get faster. Right, let's try that. Here we go. Oh, wrong one. So you're going to get a pause. There's in fact the pause is not long enough. Hang on. Let's do it twice. So you should see a definite pause at the end of the cycle. On, pause, on, pause, pause, pause. There we go. Now, this is not doing the, this is not showing the speeder up, so we'll speed it up. So instead of doing all this, we'll rem all that out. We'll just decrement the display level, so you should see it speed up rather rapidly. Here we go. It's getting quicker. Yeah, the flash is definitely getting quicker. Oh, I've lost it already. Right. Right, so we've got the computer spitting out the sequence, and it looks like the leveling's now working. Now we need to do the human part of it to press the buttons when they think in the right order. And if they press a button that's not right, they lose a life. They lose a life. And can get get them to continue, or do we get it to start again? Ooh, that would be nasty. If they lose a life, do they have to start the sequence again? Or do we allow them to press the right one to continue? Alright guys, I thought I might get this done. I thought I might have got this done in one night. Looks like I'm not going to get it done in one night. We'll do another stream after Christmas on this, where we'll try and do the human part of it. I might work on it in between to help it along so I can get it submitted, but we'll definitely do a stream in between in between Christmas and New Year. I'm only going to do one next week. Because it's Christmas, things to do. Infinite lives. All right then. Yeah, we'll get this done on stream next stream in between Christmas and New Year. We'll try and see if we can finish it off. I'll work on it in between, and we'll get it from there. Have a great Christmas, guys. I hope Santa brings everything that you wanted, and I will see you. Is Proton streaming? Right. Looks like he's going to be our victim today. Thank you very much, guys, and you too. All right. So I'll talk to you in Discord, land, and all that. But I'll see you after Christmas. Right. Let's do a raid. You said Proton streaming. Oh yes, he is. Here we go. Let's go visit Proton. Take care, guys. Have a good one. Merry Christmas to you all. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.